Okay, 13.7. This is kind of a section on the way to our bigger goal. Our bigger goal is to start doing word problems associated with sinusoidal graphs. So we're going to model things that spin around or swing back and forth, or anything that could follow a sine or a cosine graph. Before we get into the word problems, we need to come up with a way to look at a graph and name the equation that goes along with it. So we've been graphing sinusoids. We're just going to reverse that process and start with the graph and then write the equation that goes along with it. So here's an example graph. This graph I'm going to draw like this. First thing you need to realize is that any one of these graphs could be represented by a sine or a cosine, or a negative sine or a negative cosine. They all could, be slid down the axis a little bit, and any of those four options would work. We usually, and according to our book, we're going to use positive cosines. So our model is going to start at the top, like a place like this, and one full cycle will end back at the top again. It could be a sine. If you choose this as your starting point, then this would be your kind of ending point. And you could do a negative cosine that started here and ended here, or a negative sine that started here and went down and ended here. So let me get rid of all that. All that's to say, we're going to use positive cosine. For no other reason, we'll all be on the same page, and it'll be easier to compare answers and easier for me to tell if you know what's going on. So if you remember the four possible translations that we had when we graphed sinusoids. This one's in degrees, as you can tell by the axis. It's implied that the 90, the 180, the 270, 360, those are degrees. I used A, B, C, and D. Make that a theta since we're in degrees. And let's just take from the graph what all changes have been made, and then we'll put them in the spots of A, B, C, and D, and that'll be that. All right, that's our big goal of the day. Look at a graph and come up with its equation. All right, so what are the things that have happened to this graph? First of all, A, that's our sinusoidal axis. This graph has a sinusoidal axis right here of -1. So my A is definitely going to be a -1. B is the amplitude. All right, this graph goes up and down 2 from its sinusoidal axis. So B is 2. All right, that part is nice and easy. And in real life, these numbers might not be like 1, 2, 3, and 4. They might be, 600. Like if we're talking about a mountain range or a roller coaster or a Ferris wheel, these numbers might not be nice, simple little graph numbers like 1 and 2, but they'll be more real-world numbers. All right, so let's talk about C and D. The number here, that's C, and the number right here for D are the two that take a little bit more effort. D is not so bad. This graph, remember, if we're doing a positive cosine, and by the way, we could do a million different versions of a positive cosine. We could do a positive cosine where this peak is considered our starting point, but if you slid the thing down the axis another 180 degrees, then this thing would be the starting point. So you could, slide these graphs, and because they're periodic, they just keep landing right back on top of themselves. So usually what I'll do is I'll just start with the first peak to the right. So this one, if I consider an original cosine graph, would have gone right here. I've slid that peak over 90 degrees. Let's get rid of some of that, and I'm going to say minus 90 degrees. All right, that's a negative 90 is a right shift of 90. If we were modeling this with a positive sine, then that would be a 45, because this would be our starting point, and it has been moved 45 over from the original starting point at the origin. All right, so now we have one left, and that's the C. Remember, C is the number that determines the period of the function. We used to do 360, since this is a cosine graph, Remember, tan and cotan would have been 180. But we would have done 360 over whatever number is in that location for C, and we would have gotten the new period. Period used to be the unknown, and we'd use that to draw our new graph. But since we're given the graph, we need to find C. C is our unknown. So 360 divided by C is the period. And the period is how long this graph takes to repeat itself. So that's this distance right here. All right, this graph repeats itself every 180 degrees. From 90 to 270, that's 180. Every point back to a starting point, you know, from here to here, from bottom to bottom, it's also 180 degrees. Any, you know, and by the way, those are just important landmark points. From here, some random point on the graph, to that same point, that's also 180 degrees. No matter where you look, the graph repeats itself after 180. So we're going to fill that in for the period. And this is a pretty basic example. We get that C must be equal to, because 360 divided by 2 is 180. So there you go. And that is the equation of that graph modeled with a positive cosine. There are infinitely many more graphs we could do with positive cosine, and then there are 3 other versions, a negative cosine, positive and negative sine, but we're just going to go with cosine, so we're all doing the same thing. So this one, because we've been graphing, should be pretty intuitive and make a lot of sense. Hopefully that's the case. We'll practice some in class, and then we'll get to the word problems, which are the good stuff. So this might be an all-time record for short video of the year. Hope you've enjoyed it. See you in class. Young out.